Hello, dear students. This is your Jagan sir, and welcome back to our YouTube channel, Physics with Jagan sir. And I hope all of you are doing very good. And we had successfully completed five classes in Newton's laws of motion, and this is the sixth class. And so far we had completed Newton's first law, Newton's second law, Newton's third law, and after that we have seen problems connected with the thread and problems based on normal force. And here we are going to see a problem. And yesterday we have seen the problem that the mass of the thread is not considered into account. When we are solving the problem, the mass of the thread is not considered. And here we are going to solve a problem where mass of the thread is also considering. Then first one is mass of the block is capital M, mass of the thread is small m. And here a block of mass m is being pulled with the help of a string of mass m and length L. The horizontal force applied by the man on the string is, that means this is the string, and if I want to draw free body diagram for the string, then force F is acting in this direction, tension will be act in the leftward direction, right? Find the force exerted by the string on the block and the acceleration of the system, first point. And if I want to draw free body diagram for block, then block is being pulled with the thread having tension T, and ultimately the whole system is attaining an acceleration A. The whole system is attaining an acceleration A. That acceleration is equals to set of all the forces acting by total mass, then acceleration is equals to only one force, which is the force due to human being is acting in this rightward direction. So F by capital M into M. This is what is the acceleration of the system. Now, second point is for thread, if we write Newton's laws of Newton's second law, sigma F is equals to ma. Then for thread, F is acting in the rightward direction, tension is acting in the leftward direction, and mass of the thread is m, acceleration is a. And similarly for block, right? For block, see here, because of the tension force only the block is moving in the rightward direction, then set of all the forces acting is equals to mass into acceleration. Set of all the forces means only tension force is acting, mass of the block A, m, and acceleration of the system is a. Now T is equals to m F by m plus m. This is what is the tension in the string. So find the force exerted by the string on the block. This is the force exerted by the string on the block. And the acceleration of the system is F by m plus m. Find the tension at the midpoint of the string. The second part of the question is find, that is, thread has been divided into two parts. Find the tension at the midpoint of the string. That means this is the midpoint. Mass is small m by 2. Its mass is also small m by 2. And here force is due to human being. Tension is acting here. Again tension. And the whole system is having combined acceleration as we have seen as F by m plus m. This remains common. Find tension at the midpoint means, see here, F minus T is equals to, and mass of this block, mass of this one is equals to m by 2 into A, and mass of the remaining portion is equals to, for thread, for block plus half of the thread, which is equals to sigma F is equals to ma, and set of all the forces acting is only tension force is acting on this system, is equals to mass of the block plus mass of the remaining thread into acceleration, right? And we know that acceleration is equals to m plus m by 2 F by m plus m. This is what is the tension at the midpoint of the thread. This is the tension at the midpoint of the thread. And third question is find the tension at a distance x from the end at which the force applied. See here, it is one of the most important concept. Suppose here distance is a distance x. Find the tension at a distance x from the end at which the force is applied. This is the point where force is applied, and this is the length x, and this is the remaining length L minus x, its mass is m. Then what would be the mass of this one and what would be the mass of this one? For that purpose, we can consider by using linear mass density. Lambda is equals to total mass by total length, right? The mass of the, let us say, A part, let us say it is B part. Mass of A part is equals to lambda into L minus x, that is m by L minus x, and mass of B part is equals to m into is equals to is equals to lambda into x, that is m by L into x, m by L into x. Now by using Newton's second law for thread having length x, then we can say here only F is acting, here tension is acting. So F minus T is equals to mass of the thread. Here mass of the thread is m by L into x. So m by L into x into acceleration, right? Now similarly for block and remaining thread, if I am applying Newton's second law, sigma F is equals to ma, and only one force, tension force is acting, and mass of the block plus remaining portion is m by L into L minus x. This is total mass, and acceleration of the complete system is F by m plus m. This is the tension force acting at a distance x from the point where the force is applying, right? Then next concept is, and I hope this is the problems connected with the strings has been completed without mass and with mass of the string. And next is we are going to see a new concept, that is one of the most important and one of the confusion topic, that is known as pseudo force. Pseudo force. See, this is one of the important and confusion topic. And see here, this topic, first of all, I would like to recall a small concept which we have seen in our yesterday class. Here, a weighing machine is present. A person is standing on it. And if we are measuring his weight, what we will measure? The normal force applied by weighing machine on the man is the reading of the weighing machine. This is the first point. Now let us see here. The case says, and mg is the force due to gravity, and if the whole system is moving in the upward direction with an acceleration a, Now let us see, m is equals to 4 kg. Now here we can consider by using Newton's second law for an observer on the ground. For observer on ground, we can save one point. Set of all the forces is equals to mass into acceleration. Very good. And this is the whole system is moving with the acceleration a. Set of all the forces means n minus mg is equals to ma. Let it is moving with the acceleration 2 meter per second square. Let us assume like this, right? Now, normal force, that is N is equals to mg plus a, then N is equals to 4 into 10 plus 2. This is 12 into 4, 48 Newton. This is the weight. This is the weight observed by the observer who is standing on the ground. It is very clear because this was the concept we have seen in our yesterday class. Now the situation is arised. In that particular situation, suppose here a person is present. Here a person is present. He is in the elevator. He is in the elevator. Now observing 10 minutes. Observing by person in elevator, observing a person in elevator, we can see this. If he observes, he is at rest position with respect to him, right? He is at rest position with respect to him. So according to his perspective, he can feels that N is acting in the upward direction, mg is acting in the downward direction, and if he is at rest position with respect to him means obviously N is equals to mg. That is N is equals to his mass is m10 is equals to 40. And if a person outside the elevator is observing 48 Newton, if a person inside the elevator is observing 40 Newton, for the same candidate there are two answers. Is this is the correct? Obviously no. Obviously no, because a candidate is present means obviously he has to ask the same answer in every frame of reference. Am I right? Now, to rectify this problem, we are using a new concept called as pseudo force. And this pseudo force concept helps us how to resolve this problem. See here, whenever a person who is inside the elevator is observing, he is the observer, and it is moving with the acceleration a, and normal force is acting in this direction, mg is acting in this direction, everything is same as I drawn in the previous case. Now the situation says that whenever he is observing, whenever the person who is inside the elevator is observing this candidate, he says that set of all the forces acting is equals to ma, which is correct only. But here, what are the set of all the forces acting is N acting in the upward direction, mg is acting in the downward direction. Now the observer who is in the non-inertial frame of reference, that means who is in the accelerated platform, he himself feels that there might be a force acting in the downward direction. That means this force has to be applied in the direction opposite to the direction of motion. If the elevator is moving in the upward direction means we have to consider this in the downward direction, and which is equals to, as per our observation, he is at rest position with respect to him, so again 0. Clear? Now the extra term which was added by this observer when he is in the accelerated platform, this extra term is known as pseudo force. And observe very important point, the mass what he substituted is the mass of the object for which his observation is taking place, and acceleration means acceleration of the elevator or acceleration of the frame of reference in which he is moving. And you have to remember this case when observer is in the elevator or accelerating platform. Clear? Now if he substituted the values n minus 4 into 10 minus 4 into 2 is equals to 0, then n is equals to 48, which is similar to the case when observer on the ground. So he has to apply a pseudo force, a fictitious force, which is actually not present physically. It is the force only he himself feels that it might act on the object when the object is in the in the accelerator platform along with the observer who is also in the accelerator platform. I hope I am very clear in understanding the pseudo force concept. Am I right? Then, based on this concept, let us see some numericals. See, the first case is here what the problems I am discussing is, these are the conceptual and application oriented problems. try to concentrate heavily, right? See, the situation says that here is an angle theta. The whole platform is moving in the forward direction with an acceleration a. With an acceleration a bob of mass m is equals to 50 grams. 50 grams is suspended from the ceiling of a trolley by a light inextensible string. If the trolley accelerated horizontally, the strings makes an angle 37 degrees. 37 degrees with the vertical. Find the acceleration of the trolley. See here, we can consider the observer is inside the trolley, which is moving with the acceleration a, and as I told you, the observer can feels a fictitious force which should be opposite direction to the direction of motion. That means that fictitious force will act like this, right? And next point, this is actually pseudo force, fictitious force, right? And this is the tension. We can write here, it is theta, means this is also theta, this will be t cos theta, this will be t sin theta, and this will be mg, right? Now in along horizontal sigma f is equals to ma. See, t sin theta is acting in the rightward direction, t sin theta, and minus ma, and according to him it is at a rest position, so m into 0. Clear? Then t sin theta is equals to ma. Let it be equation number 1. Similarly, along vertical sigma f is equals to ma. T cos theta is acting in the upward direction, mg is acting in the downward direction, m into 0. Then t cos theta is equals to mg. It is the second equation. Now dividing 1 by 2, so t sin theta by t cos theta is equals to ma by mg, mm. Then tan theta is equals to a by g. The acceleration of the system is g tan theta. G means 10, tan 37. Tan 37 means 3 by 4, which is equals to 2, 5, 15 by 2 meter per second square. I hope I am very clear to make you to be comfortable with the concept and subject, right? The next point is, see here, we will see one more problem, again one more application oriented problem, right, based on pseudo force. See, the question says that, second one or third one, actually third one or fourth one, whatever that may be, the question says that a block is present. A block of mass m is placed on an inclined plane. This is the block. This is the block placed on an inclined plane. With what acceleration a towards right should the system move on a horizontal surface so that m does not slide on the surface of the inclined plane? That means the whole system has to move with certain amount of acceleration. Even in such a case, the mass should not slide on this block, wedge. Let us assume this is wedge, this is block, and what is that acceleration does not make my block to slide on the inclined plane, and assume all surfaces are smooth. Very good. Now let us see an observer on the inclined plane. He feels that this mass is attaining a pseudo force in the direction of opposite direction to the direction of motion. And as I told you, mass m, the mass of the block, acceleration is the acceleration of the system. And next one is, here normal force is acting, and ma will have two components, and this is theta, means this will be theta, this will be ma cos theta, this will be ma sin theta, and here mg will act in the downward direction, right? And normal, see very carefully, if it is theta means obviously this will be 90 minus theta, again this will be theta, so it will be n cos theta, it will be n sin theta, right? Now along horizontal direction, along horizontal direction, right? We can write sigma f is equals to ma, then n sin theta minus ma is equals to m into 0. See here, this is the acceleration of the block with respect to the observer, and with respect to this observer, this has to be at rest position. That's why here I am representing here with the acceleration 0. But this is the pseudo force, which is this one. Clear? Right. Then n sin theta is equals to ma. Let it be equation number 1. Similarly, along vertical direction, n cos theta is equals to mg. N cos theta is equals to mg. Let it be equation number 2. Sigma f is equals to ma. Obviously, along the vertical direction, the object is not moving. That's why I am taking acceleration as 0. N sin theta minus mg is equals to 0. N sin theta is n cos theta is equals to mg. It's clear, right? Now they are asking us to find with what acceleration, right? Acceleration of the system we need to find. So n sin theta by n cos theta is equals to ma by mg, then a is equals to g tan theta. This is what the acceleration of the system, so that the block would not move on the inclined plane, right? I hope you might understand the concept very clearly, and application part also you might understood very clearly. And if you have any queries, you can let me know through the comment box, right? And for daily practice sheets and weekend examination papers, you can follow our Telegram channel, Physics with Jagan sir. Have a great day. Take care. Bye bye.